Now here in section 6.4, we're actually going to calculate some probabilities. And the way we're going to do this is we're going to assume, that this sample space, that S, is what is called equally likely sample space. And that means that every individual event in the sample space is just as likely to be selected as any other. So if we were to randomly select a number out of this group here, we're just as likely to get a 1 as a 2, or a 3, or a 4, right? They're all equally likely. To put it in symbols here, the probability of getting a 1 would be 1 out of 6, right? Because there are 6 possibilities. They're all equally likely, so the probability of getting a 1 is 1 out of the 6. Probability of choosing a 2, that's also 1 out of 6. And ... the probability of getting a 6 is also 1 out of 6. So in general here, we're going to write a formula for this. So in general, the probability of some event is going to be, now as long as the sample space is equally likely, the probability of some event is going to be the number of elements in the event divided by the number of elements in the sample space. Let's just look at this a little bit more here. What we want to know is what is the probability that some event E happens? And as long as the sample space is equally likely, we're going to count the number of elements in the event and then divide that by the total number of possible things that could happen. So back in our first example here, what's the probability of getting a 1, right? So let's look at this formula. What's the probability of getting a 1? So if I write that according to the formula, the probability of getting a 1 would be the number of elements in the event divided by the number of elements in the sample space. Well, there's only one element in the event, and there's 6 elements in the sample space. Another example might be this one here. So another example, same sample space. What's the probability of getting a 1 or a 2? Right, so we're going to reach in and we're going to grab one of these numbers, right? Just select one of them. What's the probability that it's a 1 or a 2? Well, because it's an equally likely sample space, this is going to be the number of elements in the event divided by the number of elements in the sample space, which is, now there's 2 elements in the event, right? A 1 and a 2, but there's 6 elements in the sample space, so all in all, the probability here is 1/3. And what this means is, maybe if you were to keep doing this experiment over and over and over and over again, maybe out of every 3 draws, one time out of every 3 draws, you would see a 1 or a 2 on the average. Let's try another example, and then we'll get to the problems in the problem set. Suppose we have an urn, and in this urn we have, say, 7 blue bottles and 5 red bottles. So all in all, we have 12 bottles, and what we're going to do is we're going to select 4 of them. Now let's just assume that all the bottles are the same size, so that each bottle, when we reach in, right, we're going to reach in and grab 4 bottles. Every bottle is just as likely to be drawn as any other bottle. So our sample space will be equally likely. So let's ask this question here. What is the probability that when we reach in and grab 4 bottles at random, what's the probability we get 3 blue and 1 red? So this is going to be the number of elements in the event divided by the number of elements in the sample space. This in turn will be, now when I do these problems, I often like to get the number of elements in the sample space first. So I'm going to look at the denominator here. Now the denominator is the number of elements in the sample space. What's the sample space? Well, what we're doing, here's our experiment. Out of 12 bottles, we're selecting 4, right? There's no order implied here, so this is just a combination of 12 things, choose 4. So the number of elements in the sample space is 12 objects, choose any 4. And the numerator, all right, this goes back to some of the problems we were working in chapter 5. What we want here are 3 blue and 1 red. So we have 7 blue to choose from, and we want 3 of them, so this is going to be out of 7 blue, choose 3, and times out of those 5 reds, choose 1. Okay, so we've really got the problem solved right here, but if we compute that out, I use my calculator. I got 0 point, I'll round off to 4 places as we typically do in probability. I got 3535. So what that means, now if I round it off a little bit more, just to 0.35, okay, let me try it, 0.35, that's 35 out of 100. So if we were to do this experiment 100 times, reaching into this box here and grabbing 4 bottles, about 35 of those 100 times, we would expect to see 3 blue and 1 red.